In this problem we have a rotating record with an initial angular velocity of 0.5 radians per second, and it has a moment of inertia of 0.0043 kilogram meters squared. Now there's water dripping on the record 0.1 meters away from the center, and this water adds up to a mass of 75 grams after a certain time. So we have 75 grams of water 0.1 meters away from the center of this record, and we want to figure out what is our new angular velocity. How fast is this record turning after all this mass of water is on it? So what we can do is we use the conservation of angular momentum. So we can say initial angular momentum equals final angular momentum. Now our initial angular momentum is defined by moment of inertia times angular velocity. So this is like our mass term, and this is our velocity term, which it relates it to linear momentum. So our initial moment of inertia and our initial angular velocity is equal to our final moment of inertia times our final angular velocity. Now, we know our initial is 0.5 radians per second, and we know our initial moment of inertia is 0.0043. So we have to figure out the final moment of inertia, and then we can figure out our final angular velocity. So to figure out this, we look at the water that's dripped on here. So our total moment of inertia is going to be equal to our initial moment of inertia plus the moment of inertia that is added by putting the weight of the water there. I have the water. So our total moment of inertia is II, 0.0043. Now, moment of inertia, if we look at this, is just a thin hoop a certain distance away. And for a thin hoop, the moment of inertia is mr squared. mr squared. We know the mass of the water, and we know the radius of the water. So we can figure out our total moment of inertia. 0.0043 plus mass, 75 grams in kilograms, is 0.075 times the radius, 0.1 meters squared. Add that up, and we get a total moment of inertia of 0.00505 kilogram meters squared. We use this in this formula, and we'll figure out our final angular velocity. So initial moment of inertia of 0.0043 times our initial angular velocity of 0.5 is equal to final is 0.00505 times omega final. So all we do is divide that over. Omega final equals 0.0043 times 0.5 divided by 0.00505. Omega final is 0.43 radians per second. So final answer, 0.43 radians per second.